In this we will translate points. Here we are doing a composition. So we have two transformations. Perform the double reflection in the coordinate plane below and identify the equivalent translation rule. So first we're going to go ahead and identify our coordinates for our original pre-image. So we have triangle ABC, coordinates for A, right 6, up 7, so 6 comma 7. Coordinates for B, right 9, up 5, so 9 comma 5. Coordinates for C, point C, are right 10 and up 2, or 10 comma 2. Then after that first transformation, which is a reflection across the line x equals 1, we end up with triangle AB, A prime, B prime, C prime. So we have points for A prime, B prime, C prime. And then after the second transformation, which is going to be when x across the line x equals -5, we end up with triangle A double prime, B double prime, C double prime, which will have these double prime points, A double prime, B double prime, C double prime for the second transformation. When you're doing a composition, you have to do the transformation on the right first, and then the one on the left, second. Because the order matters. If you do it in the opposite order, it will affect your final answer. So you need to go from right to left when you're doing a composition of transformations. So you're doing more than one. So the first one we're going to do is we're going to do our translation, but we're going to try to we're going to do the first one, and then we're going to see if we can identify a pattern. So first one, we've got point A. We've got to transform it across the vertical line x equals 1, which is this green line here. We can count 1 to the perpendicular distance, which is this line here running through green. So that's 1, 2, 3, 4, 5. Again, perpendicular just means it makes 90 degrees with it, but that's a distance of 5. And then we're going to count 5 on the other side. So 1, 2, 3, 4, 5. So point A prime goes here. The coordinates for A prime are -4 and +7. Now at this point, we're going to see if we can identify a pattern that will help us finish this a little bit quicker. So when we do, recall, we developed a rule for reflecting across the y-axis. And when we reflect across the y-axis, the rule was that your x would be multiplied by -1 and your y would stay the same. Now notice that when the y-axis is the same as the vertical line, when x is equal to 0. So when x is 0, that is the vertical line that goes through the x-axis, or through the y-axis. And so notice that all we're doing here in these transformations is we're doing reflection. We're going to reflect across different vertical lines. One vertical line is x equals 1, and the other vertical line is x equals -5. And so just as when we reflect across the y-axis when x equals to 0, we notice that we're not changing levels. We're not getting any higher or lower. So our y value is going to stay the same. So anytime you're reflecting across vertical lines, your y value is not going to change. So we can see that our y values aren't changing. So we can go in our problem. So this double prime, it's still going to be 7. Here it was 5. It's still going to be 5. Here it was 2. It's still going to be 2. And this one is still going to be 2. And this one is still going to be 5. So our y values are not changing when we reflect across vertical lines. All right. What else do we notice? We noticed that when x was equal to 0, we multiplied it by -1. So here, if we had multiplied this across the line x equals 0 across the y-axis, we would have, if we did that to a, we would have ended up with a being 6, a prime being -6, +7. But here we actually ended up with -4, +7. Okay, let's test it again for B. So B here, it's a distance of 9 from the green line. So we'll go a distance of 9 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see those coordinates are -8, +5. -8, +5. Now notice if we had reflected B across the y-axis, we would have ended up with -9 and +5. As opposed, all right, we got to correct our B down here. Let's just double check it again. So that's 1, 2, 3, 4, 5, 6, 7, 8. Now we're going to count 8 on the other side. 1, 2, 3, 4, 5, 6, 7, 8. So it's actually here. All right, so that's our coordinate for B prime. All right, so we've got it correctly this time. So -5, -6, -7, 5. So it's actually -7, 5. But again, if we had reflected it across the x-axis, it would have been -9, 5. Now notice a pattern. See that our x's are actually, that we're reflecting across the line x equals 1, are actually a difference of 2 from what we'd have gotten if we had done our reflection across the y-axis. So this one is 2 less, this one is 2 less. So we're seeing a pattern. The pattern seems to be, if we had to write this as a rule, we would take x and multiply it by -1, but then add 2 to it, and our y is staying the same. So this seems to be the rule we end up with when we're reflecting across the line, the vertical line, x equals 1. It seems that because of the x equals 1, that 1 means we've got to actually increase our x by 2. So we're going to use this rule to get the rest of our to get coordinate C and see if it works. So for C, we're going to multiply 10 by -1, so get -10. And then we're going to add 2 to it. That'll make that -8. And we'll check that. So C, we're saying, is left 8 and up 2. So we're saying this is our C prime. And we can count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side, and 1, 2, 3, 4, 5, 6, 7, 8, 9 on that side, and up 2. So it works. Now let's see if we can do the same thing for our A double prime. This time we're reflecting across the vertical line x equals -5. So we're reflecting, so A double prime is going to be on this side, B double prime and C double prime are going to end up on this side. So let's go ahead. This time we're going by -5 instead of by 1. So it seemed that we doubled it last time we. All right, we're going to do it the long way again. So we got A prime here, reflecting across the purple line, x equals -5. So A double prime will be right here, 1 and 1. So this one is A double prime. We'll do it in a different color. We'll do it in a different color. So we've got A double prime. And then we've got point B prime, which is a distance of 2 from this vertical line. So 1, 2. This will be B double prime. And C double prime, which is a distance of 1, 2, 3 from this vertical line. So 1, 2, 3. C double prime. So our final coordinates for A are -6 and then up 7. And for B prime, -3, up 5. And for C double prime, -2, up 2. So those are our coordinates. Let's see if we can see a rule for this. So again, looking at the first one, it looks like this time, instead of being, if we had reflected across the x-axis, this time instead of being at 6, it drops by negative 12. Okay, it dropped. So looking across each of the points from the original to the from the pre-image to the final image, we see that we are dropping by 12. 6 minus 12 will give us negative 6. 9 minus 12 will give us negative 3. And 10 minus 12 will give us negative 2. So we're going to the left 12. So we can just write this as a translation rule. And our translation rule would just be that for x, we're going to go to the left by 6. So we can write that as 6, or negative 12. We can go to the left by 12, so negative 12, and that our y is not changing. And our y is not changing. So we can leave it as just y. Or 0 for the second part. We can write it in vector notation, which looks like this, or we could also write it this way. We could say x, and then we're going to the left by 12, and then y is not changing. Either way will work. These are two ways of writing the translation.